Okay, in this example, we're starting with an equation and we're asked to find the usual variety of information and then produce a sketch. Okay, now what we're looking at here is an equation, and again, the first thing to do is recognize, okay, we're working with y squared, so I'm going to have a concave, probably right parabola. It's positive y squared, so it is concave right. We have to get the information in terms of, well, first of all, the vertex, and the vertex is found by y minus h squared equals, come on, equals 4, sorry about that, try that again, 4a, can't write up here, x minus k. Okay, sorry about that messing writing. But we're aiming to get that squared. We're aiming to get this. So we haven't got one of those. So what I'm going to do first of all is just get this in terms of a single y. Okay, I'm going to get rid of all that writing. And right. So what I'm doing is I'm going to divide everything by 4 because that gets me a monic. Okay, that y becomes a single. That's a 3, and okay, I'll come back to that. That's a quarter. So 1 divided by 4, take that over to this side because I want to complete the square. So in blue is what I'm left with. There's my negative 1/4 that I divided by 4 and brought it over. And of course, 4 divided by 4 leaves me with 1x. Now again, our method of completing a square, halve that, square it. Now halve of that means that we have brackets then left over that look like this, y minus 3 on 2, all squared equals, and that resolves to be 2. Okay, so now we're working with a parabola and I can figure out the vertices and the other information. Now, of course, I need y squared equals 4ax. And here's how I figure this out. There's x plus 2. Now the x has a coefficient of 1, which is what I want inside this bracket. So the coefficient of this whole thing here is 1, but I have to have it in terms of 4a brackets. So 4 times what equals 1, and that's where the quarter comes from. So now we know that the focal length a is a quarter, and these 2 points are my vertices. So negative 2, positive 3 on 2. So let's get this down now. We're looking at 2, did I say? No, negative 2 and positive 3 over 2. Negative 2, positive 3. So that point just there, which is negative 2 and 3 over 2. Okay, now, because this is such a small graph and the scale's not so great, I'm just going to really zoom in on this now. Now, we had a focal length of a quarter. Now, this is an example where you're really going to have to plan your graph before you draw it. So if this didn't have any grid here, I'd put this point right up somewhere up here, give me plenty of space to work in so I can show quarters much more easily. Unfortunately, I'm going to work with this graph, so I'm going to use a different color just to, I suppose, highlight the difference. Okay, so there is my focal points, and this line here then becomes my directrix. This is y. No, it's not. This is y equals, well, 3 on 2 minus a quarter is a 5 on 4. Okay, and so our parabola looks something like that. And again, we're going to have to find out that point there. Where does it cut? Let's just reduce this and have a look now. Okay, so you need to find that point of intersection on the y-axis. But just to recap, if we start with something like this, your job is to get it into a perfect square, in this case dividing. Okay, remembering that the x and the y's, whether they're inside the square or inside the square, or just these brackets here, in whether this is x or y and this is x and y, they have to be 1x and they have to be positive, 1y positive. Then we can sort out the rest of the information. Okay, so label the focal points as, -2, 3 on 2, 7 on 4. Okay, so -2, 7 on 4. And there's your information. Labeling this, of course, as well. Okay, so there's how to interpret one of these questions.